What's the one thing that people love to brag about with their vehicles? Manufacturers are constantly advertising it, and engine tuners are constantly chasing it. That's horsepower. That sound effect was terrible. I apologize for that. But today, we're breaking down something you hear about all the time in the diesel world, but a lot of people don't actually understand what it is. You'll learn what diesel horsepower really is, how it's created, and how it's different from torque. You'll also learn that the horsepower number on the brochure isn't always what it's cracked up to be. By the end of this video, you'll understand horsepower from a technician's point of view, not just a spec sheet. So what exactly is horsepower? At its core, horsepower is a measure of work over time. Horsepower answers the question, how fast can an engine do work? While torque tells you how hard the engine twists, horsepower tells you how fast that twisting work is happening. That's why two engines can make the same torque, but one can feel way stronger at higher RPM. But where did this horsepower term come from anyway? Well, the term horsepower goes way back to the 1700s. A Scottish inventor and engineer back in the 17 and early 1800s named James Watt needed a way to explain engine power compared to the traditional power source of the time, which was horses. He made such a lasting legacy in engineering that the term for power, watts, is now named after him. But he calculated that one horse could move 33,000 pounds 1 foot in 1 minute. I wasn't there, so I don't know how he actually measured that, but nonetheless, 1 horsepower became equal to 33,000 foot-pounds of work per 1 minute. And that definition still applies to modern diesel engines today. But for new diesel technicians, here's the formula every diesel tech should be familiar with. Horsepower equals torque times RPM divided by 5,252. Now that number 5252 comes from unit conversions of torque, which is measured in foot-pounds, and engine speed, which is measured in RPM. There is, of course, math to prove this, which you can find on your own if you're interested, but this horsepower formula explains something critical. You do not get horsepower without RPM. Diesels make big torque, but because RPM, or engine speed, is limited, horsepower is naturally going to be limited as well. Now let's compare diesel engines to gasoline engines to get a better idea of how horsepower works. See, diesel engines have lower RPM ranges, higher compression ratios, a longer stroke design, and massive torque at low RPMs. While gas engines, on the other hand, have higher RPM, less torque per stroke, but higher peak horsepower numbers. Now, diesels don't make power by spinning fast, they make power by pushing hard on the piston. But how do diesel engines actually create horsepower? Well, horsepower in a diesel engine comes from four main factors. Number one, torque production. This is influenced by compression ratio, injection timing, fuel quantity, and boost pressure. Number two, engine speed, or RPM. More usable RPM equals more horsepower, even if torque starts to fall. Number three, airflow. Turbo size and efficiency, charge air cooler effectiveness, along with intake and exhaust flow all play their part. Number four is fuel control. Fuel creates energy, but only if there's enough air to burn it cleanly. More fuel without air causes high exhaust gas temps, smoke, and shorter engine life. But maybe you've heard about advertised horsepower or rated horsepower. This is where a lot of confusion about horsepower comes from. You see, advertised horsepower is the number you see in brochures or on commercials or dealer websites. This is usually the maximum output the engine can make, measured under the most ideal of conditions. It is often measured at the crankshaft and not the wheels, and while it's not really a fake number, it is a best case scenario, and not something you can expect to work with under normal operating conditions. Rated horsepower, however, is different. Rated horsepower is the power level the engine is designed to sustain. It's tested under specific standards and approved for cooling, emissions, and durability. This is the horsepower the engine can make all day, under load, without hurting itself. Commercial diesels live and die by rated horsepower, not the advertised numbers. But sometimes, however, the same engine can have multiple ratings. The same engine may be rated differently depending on application, the cooling system, emissions strategy, or in the intended duty cycle. The engine may have the same hardware, but different calibrations as well, which can change the power. Now let's use a Cummins ISB 6.7 liter as an example. Let's say it makes 800 foot-pounds of torque at 1600 RPM. To calculate horsepower, we will use the formula, torque times RPM, and divide that by 5,252. In this case, that's 800 foot-pounds times 1600 RPM divided by 5,252, which equals 244 horsepower. Just as an example, however, peak horsepower might happen at an engine speed of 2,800 RPM and 650 foot-pounds of torque. Horsepower in this case would be 346 horsepower. Again, 650 foot-pounds times 2800 RPM divided by 5252, which equals 346 horsepower. You can see in this example that while torque went down, horsepower actually went up. This is mostly due to the engine speed that increased so much to do that rotational torque work. And that's how horsepower works. Diesel horsepower curves rise as RPM increases, it peaks after torque, and drops when airflow or fueling limits are reached. So surely more horsepower is always good, right? Well, not necessarily. You see, chasing big horsepower numbers could raise exhaust gas temperatures, overspeed turbos, crack pistons, or kill transmissions. Rated horsepower exists to protect the engine, not to give the operator something to brag about to his or her friends. So now you've learned that horsepower is simply work across time. Diesels make power quite differently than gas engines, and while advertised horsepower is peak potential, rated horsepower is sustainable power. Understanding horsepower makes you a better diesel technician. But there's another concept beginner diesel techs have likely heard of that causes some confusion: compression ratios. Watch this video next to understand what diesel compression ratios are all about.